In a bioassay, what we do is for each dose, we use not just a single mouse, but a whole bunch of mice. Suppose we take n mice in one such cohort or one such group. Then for each of them, we apply the same amount of dose, suppose that is D. So we put all these mice and we apply the same dose D, and then see how many of them die. Suppose the number of deaths happens to be K. Out of N, K many died after applying a dose of D of this particular poison. Then we proceed with the math in the following way. What we can say is that the probability of X less than or equal to D should be approximately K by N, where X is the random variable denoting the lethal dose of the poison. So it is the proportion of time. You have seen this thing. It is just like tossing a coin, example. That event has occurred K times out of N trial, so the estimated probability will be K over N. Now remember that we were assuming Gaussian distribution, so we can say that phi of D minus mu by sigma, that is approximately equal to K over N. Now in this entire thing, you do not know mu, you do not know sigma, you know everything else. So if I now take phi inverse of both sides, then I can write something like this, knowing that phi is a smooth function. So here this part is completely known, D is completely known, so you can see that now there is an affine linear relationship combining these two, and the intercept and the slope, if you can figure them out, they will give you your required mu hat and sigma hat. So the plan of DJ Finney went like this. So he said that I will take different doses, and for each one of them I will take a bunch of mice. So suppose he takes doses D1 to D5, 5 is just chosen arbitrarily, and for each dose, say he will take n many mice, say 100 mice, and then apply that dose and count the number of deaths. So you have got K1 many deaths out of N in case of dosage D1, and so on for D5 and K5. Then he will just plot these quantities. He will plot phi inverse of Ki divided by N against Di's, and that is supposed to give a more or less straight line. And in fact, if it does not give you a straight line, then that will also help you to see that the xi's, those unobservable latent xi's, are actually not coming from a Gaussian distribution. So this has the diagnostic value also. And once you have these points more or less along a straight line, you can just fit a least square line, and from the slope and intercept of that, you can estimate mu and sigma square. So this thing was devised by DJ Finney and is commonly used even today. Now, Mr. Finney introduced the term Probit for this particular function, phi inverse x plus 5. You can understand the importance of phi inverse from the plot, but why did he add 5? Because DJ Finney was working in a period when there were no calculators or computers, so every addition, subtraction, etc. were done by hand. And when you do a lot of addition by hand, you need to write all the numbers in a column, one below another, and if some of the numbers are negative, then life becomes rather complicated. So he wanted to have all the numbers positive. Now phi inverse typically takes values between -3 to +3, so by adding 5 to everything, he could ensure that everything is positive. Addition was easier. Then finally he could subtract a suitable multiple of 5 to correct the result. So this function used to be called the Probit function, but of course in the modern era we do not use that plus 5 anymore. So if you hear the term Probit used anywhere, you understand that it means the function phi inverse of x.